Tom Campbell here. If you find something of significant value in our videos, please consider supporting their production through our Patreon account or through a one-time donation. The links are in the description below. Thank you and enjoy the video.
Luis, please go ahead with your question.
Thank you, Donna. Hi, Tom. So my first question I titled A Custom Party. I'm going to read it. Within many spiritual traditions, one could say religions, there's some distinctive outfit or symbol that distinguishes the one that functions as a teacher, as the guide, or sometimes just the elderly, the advanced, or more experienced. On the other hand, I've heard you say that wisdom is one of those things that either you see it or you don't, even when it's in front of you. I see a tendency lately for teachers like you to come from a more common or blended with everyone else kind of approach. And somehow, even when I have a more traditional religious background, I really appreciate your style in that it makes things more straightforward for me. What is your impression of this? Is it of any help or use in modern times to adorn wisdom for people to get attracted to it or be able to distinguish what is not obvious in plain sight?
No, I don't think it's helpful to define who is wise and who is not by what they wear. That just doesn't make sense to me. You know, oh, this person has the little green cap with the tassel on the side, he must be wise. You know, I think that's what it does. I mean, it may be that that person is wise, and maybe wise people, you know, have to go through a lot of people who gain that wisdom. Maybe they have to go through a lot of training and a lot of whatever, and maybe judgment by their peers before somebody gives them that little green hat with that tassel on it. You know, there may be a peer review for that. But I think the idea is flawed in that you shouldn't see wisdom by dress or by a badge or by a position. You know, just because you are the High Mufti or the Pope or the this or the that, you know, you've got some title that says you're wise and a spiritual person does not make you wise or spiritual person. Particularly as these organizations go on longer and longer and longer. It may have had more of a connection early on, but eventually that connection is going to dissolve. And it may come back again, but it's going to dissolve now and then. It just is, because that's the nature of people. You know, there's somebody who says, I'd like all the bennies of having people think I'm wise. I'd like the bennies of that position, but I think I know how I can get it. You know, I can make friends with this guy, play golf with that guy, have my daughter marry this other guy, and I can plan all these maneuvers and stuff. So I'll get that hat. There's always somebody who's going to work that angle, and they're going to get it, and they're not wise. And then they're going to mislead a whole lot of people, probably hurt a whole lot of people. And to say that, nah, that'll never happen. The peer system will always do it right. Well, nonsense. It won't. It might for a little bit, but you know, once you've gone through, you know, a bunch of different people get there to where you're now 200 or 300 years past the point of the origin of the organization. Now it's more politics and organizational maneuvering that gets you anywhere. How many resources do you control? You know, that becomes the big question. And then people get very good at acting wise and looking wise and saying that wise sounding things at moments when everyone's listening. You know, they come good, you know, they get really good at that. And that's not a good thing either. That starts to destroy everything. It'd be much better that if, you know, wisdom is as wisdom does. That wisdom gets pointed to as wisdom because it seems to be wise, not because it seems to act wise sometimes not. So I think it's not a good idea to put those symbols on things, because eventually it's going to unravel and create harm. And the idea of, all right, this person gets the little hat, he's wise, pay attention to him, obey whatever he says. Well, that in spiritual things is just like the guy, well, okay, he's the king, he's got the crown, that's his little hat. He's got the gold crown, you have to do whatever he says. None of that is rational. That's all games people play. That has nothing to do with wisdom or leadership. It's the wrong thing to attach attributes to things like that. Hats don't have attributes like that. So I try very hard not to be anybody's guru. I don't want that position. Now, if you read the things I write, if you hear the things I say, if you listen, my attitude is take what you can use, learn what you can learn, and toss away the rest. If it helps explain your life, then use it. If it doesn't, leave it alone. Come back later. Maybe it'll make more sense to you later. Don't force yourself to do it just because somebody else says, oh, that Tom Campbell guy, he's really wise. You should listen and do whatever he says and listen to him. That's the wrong reason for listening to me. You have to get something out of it. Otherwise, you're not ready. And to try to do something that you're not ready for is not wise. So I don't want any of those symbols because they end up being misused. Sources need to be valuable just because of who they are. I mean, look at the people who we see as really being wise people. It's not really because of their heritage or where they come from or the hats they wear or anything. We think Martin Luther King had a lot of wisdom and spiritual quality just because of what he did. Because he was black and he wanted to include the whites in this process of working together. It wasn't negative. It was very positive toward everybody. And we think of Nelson Mandela like that, and we think of Gandhi like that, and we think of the big things. We think of the Dalai Lama like that. You read the things he says, you see wisdom in it. So that's where wisdom should come from. Not because he is the Dalai Lama, he must be wise, but whoever that guy is that they pick for the Dalai Lama, he's pretty wise, because I've read what he's said and has some idea of how he sees the world. So it's that kind of thing. I think that's so much better than icons. Icons are misleading. Icons are the way that people who don't deserve power can grab power. And for way that people have not earned, other people's following, they get that following anyway, even though they haven't earned it. People follow the hat rather than follow the man. And that creates all sorts of trouble everywhere, positions of authority. So I still tell people, don't believe anything I tell you if it doesn't meet your own test of credibility from your own experience. Your experience has to be your truth. Now, maybe your experience is tiny, and maybe your experience is being misinterpreted, and maybe your experience is so small or so one-sided or whatever that you can't see a very bigger picture. Well, it's the biggest picture you can see. That's it. How is it working for you? You a happy guy, full of joy and whatever? And if you are, well, then your experience is pretty good. But if you're not, then maybe you need to broaden your horizons, get different experience, open up a little bit. So you have to let people find their own truth. You can't force it. So no, I'd say to distinguish it is not helpful. Let it distinguish itself. Yeah, people should become our leaders because they have leadership quality, not because they were the candidate put up by the party. Unfortunately, our world doesn't work that way, because in order to compete in a modern election, you need, $50 million to do it. Well, that's not helpful either. So there's ways to get around that. You could have the government fund elections, and everybody gets exactly the same amount of money and that sort of thing. You could have much tighter rules about how that's done, but we don't do that. So instead, we have this problem of getting leaders who have no qualifications as leaders, who don't really have big ideas, who don't really understand what's going on. They just have their own little narrow perspective, their bunch of beliefs, and that's it. And that does not make a leader. Leaders have to have big pictures. But so unfortunately, we don't work that way. We tend to vet everything up through processes, and then the process somehow guarantees the quality of the product, and mostly that's a failure. That doesn't work like that. Processes can be manipulated. Processes can be bought. Those kinds of things don't last long without being corrupted. It's just the nature of free will. And I should say the nature of free will within a society that has a very low quality of consciousness. That's really the corrupting power. It's not that humans are just corrupt. It's just that humans with a very low average quality of consciousness are going to just generally be corrupt. And those kind of processes are going, the little green hat with the tassel, it's just going to be corrupted eventually, because that's the nature of who we are right now. As we grow up, maybe some of these processes would work again. But why? What do they add? I don't see that they really add anything. So that's my attitude toward that sort of thing. Let something that's valuable rise to the top on its own merits. And if you can't do that, then look elsewhere. But it's got to be propped up by an organization and fed by, and kept up there by propaganda. It's just not helpful to anybody. And of course, if the words are coming from an organization, then by definition, it's propaganda. It's whatever it is that organization is selling, right? So, now it's just marketing. And we know that marketing is mostly just propaganda. It's trying to manipulate people to agree with the organization's viewpoint. That is not the way we ought to run business. But it's how we do. But we have with the internet now, we can get more up close and personal with people. We can understand more of what they say and think. We can be more open. And people who refuse to be open but keep everything closed up and only speak bullets, sound bullets, things that sound good but don't really mean much, well, those should be non-candidates. You don't even want to talk to them. But in our environment, that's required of everybody. Everybody's reduced to sound bites. And if you don't play the soundbite game, then you can't play. So that's kind of the quandary we've gotten ourselves into. And in our world, we do not teach our young people, starting from kindergarten up, we do not teach our young people how to discern facts from opinions. We don't teach our young people how to solve problems, how to think outside the box, how to be creative and seek solutions. We don't give them, we don't teach them problem solving, but we don't teach them, critical thinking skills either. Matter of fact, we suppress all that. When a student comes up with a unusual way of seeing a problem, we tell him he's wrong. When he may not be wrong, he may just be coming from it from a different direction, but that's interpreted as wrong. The teacher did it this way, you have to do it that way too. So we go out and we squish people who have these skills. And then we end up wondering why our electorate seems to be brain dead. You know, why is the electorate brain dead? Why can't they tell black from white? Why can't they see good from bad? You know, it's like invisible to them. They wouldn't know. It's because we've already beaten all the creativity and ability to do critical thinking out of them in the public schools for the most part. So then we have to resort to sound bites because anything more confuses them. So we've got an electorate that is unable to do critical thinking because critical thinking has always been punished in the school system. And, you know, you reap what you sow, right? So that's why we have an electorate that cannot discern up from down, right from left.
Thank you very much, Tom.
Thank you, Luis. Gary has a question, Tom, on physics and David Bohm, and I know you've talked a lot about David Bohm, and also it has to do with your experiments as well. So hopefully this will be a general enough question for the audience. Let's give it a go. Gary?
David Bohm was a long-time collaborator with Krishnamurti, whose spiritual ideas reflected his own theories about the interconnectedness of the physical world with consciousness. In a recently released documentary called Infinite Potential about David Bohm's life and ideas, there is a section in which it is declared that the paradox of the double slit experiment is solved by his 1952 paper describing quantum theory in terms of hidden variables. At the time it was written, computers were not powerful enough to model his mathematical equations, but 30 years later, physicists and mathematicians at Birkbeck College London used the much more powerful computers now available into a physical representation of the trajectories of the particles as they approached the double slit. They produced a moving image simulation on a screen so you could see how the individual particles effectively chose which path to follow. In other words, using his equations, you could watch the trajectories of individual particles behaving as particles and account for why they produced an interference pattern, which is described as an insoluble paradox in normal quantum theory. David Bohm does not appear to be a scientist limited by a belief in materialism. He has an expansive view of the universe, which includes the role of consciousness in his experiments. So I imagine that you might be familiar with him, and that's what Donna just said. If his theory already explains the paradox of the double slit experiment, then I wonder whether you can explain why his theory is flawed and what your experiments will show that his theory does not.
I don't know enough detail about Bohm's ideas to be able to tell you exactly what would conflict with mine. I would really like to see that part where your sentence said, so that you could watch on the screen how individual particles effectively choose which path to follow, and how they also, you can account for the interference pattern. I mean, I see that in words, but I'd actually have to see that in more than words to understand exactly how that's done, because, you know, you can't see these particles. These aren't particles you can see. It sort of sounds like you can see them, and you can see how they go through the slits. And you say you can see him with his equations, but that doesn't mean you see him at all. That just means his equations represent a logic for which it could be done. And that he also has equations that will account for the logic of the pattern. So to me, it's not clear exactly whether that works or not. Now, they may say that that's the case. I've heard this argument on hidden variables for a long time. That's gone on since Bohm introduced it. And generally, scientists have come down on the idea that there cannot be hidden variables. And there's been several. And again, these are things like I'm trying to dredge up from, 30 or 40 years ago, reading this stuff, because Bohm did his work in the 50s and 60s. This is old stuff. So a lot of the counters to it are also old stuff, and it's hard to bring them up in detail. But I think there were a few that tried to come to the conclusion that there could not be hidden variables. And I think some of that has been also more recent, shown that hidden variables could not be an answer. So I'd say it's still, in my head, it's still not a fact that Bohm and his hidden variables can actually explain this well. Now we have, like you say, there's a couple of people recently done computer work, and they've come to the conclusion that they think that what Bohm said works just fine. But you have to understand that mathematics, the equations that they look at, do not represent reality. This is a thing that's hard for physicists sometimes to get a grip on, but it's basic philosophy of science. And physicists who kind of get into philosophy as well, they realize that equations follow the logic of quantity. That's what math is. All of mathematics is the logic of quantity. It's ways that you can take quantities and things that you can do with them. Mostly it's ways that you can group them. Arithmetic and algebra, ways that you can group them, ways that you can change them. And it's all about the logic of quantity. It doesn't necessarily mean that they represent reality at all. What we do is we use mathematics to represent reality, but we do it with assumptions and with, what's the word? Maybe assumptions is the right word. We tie them together, and we tie them with assumptions, and sometimes we tie them with belief. But we say, this represents this physical thing. But most often, it doesn't really. Okay, I have a parabola, and a parabola represents a object being thrown in, say, a square law gravitational field. And if I throw something up and then it's unguided, it's ballistic, no energy there, there's no little motors on it or anything, it will always travel in a parabola. So now I can write down that, equations of motion of this thing, and it's a parabola. Well, that's true, sort of. There is no real empty vacuum with nothing in it for that to actually be true in. That's only true in this vacuum, you see. In the real world, it's not like that. In the real world, we don't have vacuums. In the real world, we don't have perfect objects. In the real world, we have air, and we have air interacting with little cuts and fissures and bumps on the material that have forces that make it spin and roll. We have all kinds of other complications coming on. So though we say this is a parabolic trajectory, that's just not true. It's just us trying to model reality with the logic of quantity. And it lets us come close. So we look at somebody fires a cannon and we kind of make a parabolic trajectory, and we can pretty well predict where it's going to hit, and we'll put in a little, we'll bring it back a little bit to go for air friction or something like that. But the mathematics does not directly represent reality. It only does partially and only with assumptions. Assumption one in this case would be there is no air, it's a vacuum. It's a perfect vacuum. All right, and that the gravitational field is always constant. It's always smooth and it's always linear. It's always pointing in the same direction. That's also not true. If you're firing something, say, like something's going to orbit the Earth, gravitational field isn't always constant. It changes all the time. So almost all the assumptions we make are assumptions that take our mathematics, out of reality and let them model something, but it's not the real world. So that's the problem with just having a bunch of equations that seem to work. The fact that quantum mechanics can do the things they do and predict the things that they predict doesn't mean that the quantum physics represents reality. Now it has to have some, or that the quantum physics equations represent reality. Now they are successful at making predictions of things. That means there's obviously some connection they have there with reality, because they can make good predictions. But sometimes they don't make good predictions. Sometimes there's problems. That's how science grows. Science starts something and they are pretty good at something, and then they say, yeah, but we're off. And then they learn a little bit more how to make it better. And they're still a little off, and then they learn how to make it a little better. And as the science goes, we get better and better at making our math suit our situation. But sometimes our math can't be consistent. We can say, well, we'll use this math at this part, and then when we get over to this part, we'll use a kind of different math, and over here we'll use some different math, and we'll put all those together, and that's fine. But that logically is not consistent. There's no logical consistency from beginning to end. So that's a problem. There's lots of ideas that seem to work mathematically that don't necessarily explain what happens in an experiment. So yeah, I've heard of David Bohm's thing, and I guess I've also heard that recently some people are supporting it, but there's some people supporting all sorts of ideas. And there's lots of claims made in science about this proves this and that proves that, and most of those just aren't true. Most of those, the statements that they make when the science becomes pop science tends to be very exaggerated over what the science actually says. That's just the nature of pop science. And it's not the writer's fault entirely. The physicists, make kind of wild claims for things, and when they talk about it in language with some hyperbole in it. Physicists do have a pretty good sense of humor. That's why we have charm particles and gluon, for things that stick things together. We make up stuff because it's fun, and people sometimes take all that too seriously. So I see science all the time. I see these headlines. It says, scientist proves virtual reality is impossible. Right, that's the headline. So you get that, and yeah, right, roll your eyes. So yeah, right, let me read that paper. So you read the paper and find out what they did was that if you have a computer and you try to compute reality from the ground up, that is from the most tiniest particles and subatomic particles to atomic particles, all the way up through molecules to everything that's going on in the world, that it's just not possible. Nothing can calculate that much that fast to make it real time for this world with the trillions of trillions of trillions of particles and so on. So they just decided that it was outrageously impossible. Therefore, there could be no virtual reality. But that's assuming that the only way to have a virtual reality is if you compute it from the smallest particles up. There's no other way to get there, you see. Oh, that was a little assumption that wasn't mentioned in the headlines. Well, science tends to talk like that. They say things and their headlines are meant to grab attention, not to further science. Headlines grab attention. And mostly the stuff they say is just wrong. If you actually read the science, you'll find they're not making those claims at all. They say those things because it's cool to say them and it makes a big splash, but when you get down to talking about it, they say, oh no, well, of course, it's just these assumptions that it's done that way. So I don't take things like David Bohm's work of the hidden variables is now shown to be okay. I kind of say, yeah, okay, I'll have to read that paper and see what it is they're really talking about. So forgive me if I don't, just jump on that because the scientists said that it was right. And I would encourage you not to do that either. Science, when it gets out to the public, is often full of hyperbole, full of claims that just aren't true, because they're trying to grab attention, and they can only do that by saying things that are zingy. So, yeah, there's all kinds of claims out there that claim to explain the double slit experiment and explain it perfectly and so on and so on, but they don't really. So I would have to look at this to see. Now, I did see that thing on David Bohm is out now. Donna sent me a copy of it actually just today or yesterday, and I didn't get a chance to look at it yet, but I will. David Bohm was a real scientist, and you know, he's high on my list of good scientists. David Bohm is up there, you know, on the top end of that list, because he was open-minded. He had a bigger picture. That made him a better scientist. But his hidden variables, my opinion, is that his hidden variables idea was a way to maintain what he knew intuitively, that physics, consciousness, the nature of our reality was all bound up together. He knew that. Yes. The double slit and the way that works and how consciousness is, it is all going to be bound up within one system, one simple system. I agree with him. He's right on that, and that was his intuition telling him that was true. But now as a scientist, his intuition wasn't acceptable. He needed to come up with some kind of a logic of how that was true. So he searched and searched for some way to do that. And the science of his time and the science of our time today required a material solution, or at least something that was quasi-material. Well, his hidden variables are that quasi-material thing. And what makes them quasi is that they're hidden. Well, those hidden things, that's sort of like the dark energy and dark matter and all the other things that you can't smell, touch, see, hear, or anything. They're totally invisible and unknown and unable to do them, but they're there because we need them to be there in order to maintain our understanding of physics as being correct. So anything that's hidden, any variables that are there but you can't see them, and I'm a little hesitant to go there, because like in politics, when they start hiding stuff, there's a reason. You know, it's because they can't show it. It's because it's not there. You know, so there are, you know, so there are hidden variables, and these hidden variables do mysterious things. And that made it quasi-material and acceptable. And there's been a lot of physicists who's followed Bohm's work because he was a good scientist. He was an excellent scientist, and he tried to get his ideas to be accepted. You know, the many worlds thing is similar to that. The many worlds people realize that the world is, quantum mechanics tells them that it is non-local. It's not just this local thing. Things seems to happen that there is no material cause and effect. Like entanglement. There is no little message that goes out and tells that other, you know, electron to flop or flip. So there is no material cause. Oh, no material cause, that's a problem for materialism. Well, then it's just non-local. That means that there's a problem for materialism, but we'll call it non-local, and now it's not a problem anymore. It's just the way physics is. So there are these non-local effects, and they came up with the many worlds for the same thing. Their intuition says that it's all holistic. It all has to all be together. But, all right, how can you have no time, but yet, sure enough, here there's a past and a present and a future. There's all those things. And there is time, because there's evolution, there's change, there's modification, there's growth. So how can there be no time? Well, break reality up into trillions and trillions and trillions of snapshots, and time is just the illusion of jumping from snapshot to snapshot. But guess what? That's an assumption that there's such a thing called jumping. There is no jumping if there is no time. So, you can't jump from snapshot to snapshot to snapshot because you can't jump because there is no time. Jumping implies time, motion, change. There's no time, there's no change. So the only way that you can make physics or make, you know, the many worlds look like it suits is to have a trick where you slip time into the jumping to show that time doesn't really exist. So you need time to exist to prove that time doesn't exist, is the problem with it. And anyway, I didn't mean to get off on that thing, but physics in general tends to be full of good ideas and intuitions that are trying very hard to find something that is quasi-material to, so it'll be taken seriously, because otherwise it's not physics. If it's not materialist, it's not physics. Or it's not quasi-materialist, then it's woo-woo, and it's not taken seriously. So Bohm wanted to be taken seriously. He did his best shot, but I've never been too good with hidden things. But I will read it, and I think Bohm was a great physicist, and I have great respect for him, and he's one of the few that had the courage to break away and say what he thought, even though it cost him, career-wise, it cost him, but he did it anyway because he knew it was right. His intuition told him this was true, and he worked very hard to get his ideas across. So I give him high points. He's up in my top 10 list of credible physicists.
Yeah, it's an excellent documentary.
Yes, I'm looking forward to it. I think it'll be great.
That section where they show the simulation, it's only about 2 minutes long, but it's very convincing.
Yeah, well, simulations can be, because what they've done is they take all their assumptions and made them into pretty pictures. And you can follow the logic of the pretty picture, and that's so easy to understand, but that doesn't necessarily mean that it works, that it really works that way. I'm sure. I've seen lots of pictures of the double slit experiment, and they're pretty convincing too, but they're mostly animations, and they show they just show particles coming through a slit or disappearing and kind of magically appearing, going through both slits. I've seen pictures of the particles turning into probability waves and waving through both slits and interacting with each other. And that's what they thought for a long time, that they were particles, or these probability waves, and the probability waves go through the slits and then interact with each other, and that's how they create particles on the other side, when that's not true either. That's just another assumption. That's not true. It's not the way it is. Particles are created by a measurement. When they have to hit the screen, because there's nowhere else they can go. They hit the screen. If they go through the slits, they'll hit the screen. They have to hit the screen at a certain time because they're going a certain speed, and there's only so much distance between the slits and the screen. So at a certain time, reality, the rendering engine of the virtual reality, is going to have to put a particle somewhere on the screen. And it needs a way to do that. It needs a structure to tell it where to put the particle on the screen. And, it does that by taking a random draw from a probability distribution. And it picks a probability distribution that creates no conflict with optics. Otherwise, you'd have quantum mechanics and optics with a major conflict between them. So it says, I'll use this probability distribution that's in consonance with optics, and that's the probability distribution I'm going to use to pick where I'm going to put points on the screen. And that's exactly what you see when you see those points fall out on the screen. So there is no particle until the measurement's made. Actually, there are no particles at all. It's all virtual reality. It's only virtual particles. But the virtual particles have to show up in a particular place where they're measured, which is the screen. And the system just needs a way to put them there. There were no particles to begin with. They were only virtual particles being fired at virtual slits, in a virtual reality. And once you get that understanding, then it changes the whole ball game of double slits. So I doubt that what the reinterpretation of Bohm, I doubt that it's really going to be a solid explanation of double slits. I doubt that it will be accepted as such, but I'm open to the possibility that it might, that there may be something there, or new people find new ideas. So I'm looking forward to finding out about it and see if indeed there is something new. But these are pretty old ideas, and we've had much better computing for a long, long time. And it just would be surprising to me that suddenly somebody's going to go, oh, well, this new computer helped me see that Bohm was right all along. That seems like a long shot, but it's possible that these hidden variables somehow work. I recall the work that was done with the basic quantum work that was done with entanglement. Trying to think of the names. Now, see, I can't remember the names of the people that did it, but they came to a conclusion that there could not be any hidden variables. That was one of their conclusions. Bell theorem, maybe. One of those things where the guys who first looked at the basic theory that kind of a lot of quantum physics rest on, and their theory was there could be no hidden variables. So that's a problem, and I don't know how this new work adjusts for that, if it does, but that's the thing about science. It's always interesting. There's always something new to read and understand and look at, and thank you very much for bringing that up, and I am looking forward to the movie. Bohm deserves much more credit than he gets, just for being an honest guy who'll stand up for what he thought, and for having excellent, correct intuition. That he wasn't able to explain that intuition with materialism. Well, we know why. We know why that was a problem. You can't explain, that you can't explain consciousness with materialism. But it's the only answer that the scientists would look at. So he tried and had to go to hidden things in order to do it. Best that he could do.
Thank you very much, Tom.
Well, thank you, Tom. When you mentioned headlines and scientists with headlines, I very clearly remembered the London Times and David Deutsch's Many Worlds discovers parallel universes headline. So that was interesting. I know that your theory, you have an identity. Reality equals information. It's just information. It's too bad David Bohm didn't use some more of his intuition. When you were speaking about the alternate reality, that seemed like an 1850s version of the Southwest. I had a glimpse of that reality. And so I think that's an example of some kind of objective evidence that you can get that, consciousness is at the root and it's an information reality. I don't know what you think about that.
I wish that David Bohm and John Archibald Wheeler had both lived, into the 2000s, into this time. They're still alive now. That would have been so amazing. But you had John Archibald Wheeler, just like Dave Bohm. John Archibald Wheeler is another physicist. It's right up there in the top few scientists who was never beaten by the status quo. He always could think outside the box. And, unfortunately, both of them passed on before they really got a chance to explore the concepts of information being reality. He knew that information was it. He said it from bit. Reality is from bits, information. I mean, he got that, but he didn't know what to do with it. He didn't know how to take that anyplace. But if he were still alive now, with virtual reality having gone past the space invaders, to something simple-minded like that, to where something that's really real, you get on a suit and you get on the platform, it's like you're there, and understanding that virtual reality and physical reality can blend into one. I think both those guys would have been on top of the virtual reality game, and they would have been, I think, natural supporters of my work, and I would have been natural supporters of their work, because they wouldn't have needed my work. They could have gotten there on their own. I think they just weren't quite born soon enough, or didn't quite live long enough to understand virtual reality concepts the way we do today.
Well, you remember that interview we did with Australian National University. You commented on what Australian National University did with John Archibald Wheeler's experiments. And although they didn't formally state that it came out to be as you have predicted, that experiment showed exactly what his thought experiment was. They didn't have the ability to perform that experiment up until recently.
Yeah. So some of the older experiments, the older scientists that we had, were really still the top end thinkers. The biggest science geniuses of all time are still those old guys that aren't around anymore. I think we haven't had any recently that are in their class yet. The Archibald Wheelers and the David Bohms, they seem to exist back in those 50s and 60s, and we haven't seen many of them that are recent, but maybe we will. Yeah, they were the best. Too bad they couldn't live another 20 years. I think it would have been a whole different ballgame if they could have.
Well, thank you, Tom, and thank you, everyone. It was really fascinating, all of your questions. We will see you next time. I know I didn't get to any of the MBT forum questions or those email questions that you sent in, and I didn't get to Ingo's question, but be assured that Tom and I will do another addendum series if we need to, because the people who submit the questions here in person are the ones that we give preference to, and they were wonderful questions, and thank you very much. But we will get to all of those questions that you have submitted through the forum and elsewhere. So thank you again, and we'll see you next time.
So long. Thank you, everybody, for coming.
Tom Campbell here. INMBT Events hope you liked this video. We now have well over 1,000 hours of free video on this user-friendly, ad-free YouTube channel. Though these videos are free to our viewers, they represent many thousands of hours in production and editing, and many thousands of dollars invested in video and audio equipment, along with the required computers and software to store and process the raw video into finished products. So far, all of this content has been funded directly out of our own pockets. Be assured, we will always continue to do what we can. It's our life, our purpose, a labor of love that we will continue to pursue as best we can. However, those pockets are not as deep as they used to be. Thus, we are now seeking to augment our resources with support from our viewers. If you find something of significant value in our videos, please consider supporting their production through our Patreon account or through a one-time donation. The links are in the description below. Thank you.